So thank you for the invite. It's really nice to be able to talk to some people who are interested in soil, hopefully as much as me. So like I said, I've been working in the field of sort of soil biology, soil health for since, well over a decade now. It's been over a decade since I got my PhD. So so when I began as a lowly PhD graduate looking at soil, it was all of these little bugs that you might see on the allotment or when you're growing, but I had probably a similar knowledge of what they were, which was not very much. So I will go into a bit of detail about the soil organisms that you might find, talk about soil health, link that in with climate change as well. So soil is so important. 95% of all our food comes either directly or indirectly from the soils. And I don't know if anyone knows, but so in the UK we import about 45% of our vegetables, which is why that can be quite unsustainable if you think about how particularly with the problems with supply chains, the worry over climate change, that we need to think about producing our own, growing our own in allotments or in our garden. And actually what's really interesting, in the Dig for Victory campaign in World War II, land was given over to grow our own vegetables. It's accounted for about 1% of the UK land area, or arable land, but actually accounted for 10% of the vegetables consumed during that time period. And since that time, the amount of allotments, or the size of the area given over to allotment growing, has decreased markedly. So there's compared to then, there's very few, very small area of area for vegetable growth. Now, soil is hugely important for a number of different ecosystem services, not just provision of food, but also a number of others, which is why we try to talk about soil health. A healthy soil is not just good for vegetable production, for food production, it's also important for the wider environment, for climate change, climate regulation, carbon sequestration, a habitat for all the organisms that live there. And if you think about soil being a base for food, it's also a base for the entire habitat. So all wildlife, all of nature exists because of the soil. And actually, when you're growing your own food, it's not just the food that is being provided by the soil. It's also, if you think about the well-being, that being close to nature in effect is given to us because of the soil. So what is happening with the soil? Why are we talking about soil health? The problem is that soil is a non-renewable resource, and soil degradation is a huge problem. Across the globe, about 30% of soils have become degraded. Now, what's also really important is that soil contains a large amount of carbon. So carbon stored in the soil is really good to reduce the risk of climate change. If it's released into the atmosphere, more likely to increase climate change. So what we want to do is keep carbon within the soil. And in the UK, we have about 10 billion tons of carbon within the soil. And this is actually equivalent to about 80 years worth of greenhouse gas emissions. So if we released all of the carbon within the soil at once, we would have a massive spike of carbon released into the atmosphere, which would really hit climate change and really lead to large problems occurring. Now, actually, UK agriculture is relatively climate not very damaging for climate. It only attributed about 10% of greenhouse gas emissions are because of agriculture. So we talk about agriculture being really bad for climate change, but actually, at least in the UK, so if we talk about what's farmed in the UK, it's not actually that terrible. So there's something to consider when we're talking about reducing the amount of farmland and instead importing food from other sources. We're just exporting the problem of climate change, which obviously doesn't work because the whole globe is affected. So within the UK, so thinking about carbon, actually, studies were shown that soil carbon can be about 250% higher in allotments than in conventional arable or horticulture. So if you think about that on a scalable basis, the more allotments we have, potentially the more carbon which could be stored in the soil, which then actually help in reducing climate change. So a really, really good idea. Now, allotments, and also when you're gardening, when you're trying to produce fruit and vegetables, allotments are actually considered quite a high quality soil, usually because we're doing good gardening practices. You're potentially putting a lot of organic amendments on the soil, fertilizer, animal manures or composted food. You're not using pesticides or insecticides. You're keeping it very natural. There is quite often a lot of digging involved, and I might move on to that in a minute. But digging quite often, basically, it shakes the entire world upside down for all the organisms living in the soil. So it can reduce soil biodiversity and soil organism numbers. Another study showed that bulk density, which is a measure of soil structure and an indicator of soil health, was actually 10% lower in allotments than the surrounding agricultural lands. Now that shows that there's greater porosity, greater airspace within the soil and allotments in comparison to the surrounding agriculture. I really like this diagram. It just shows you how the different rooting systems can, from different plants. And depending on the soil type and compaction level and nutrients will affect what plants can grow. And so if you've got compaction, it'll obviously have ability for roots to go through the soil to greater depths. But also different plant types have different rooting structure. So some, for example, can have a big tap root, which are better able to push through compacted soil. Whereas some are more branching, so better able to get a greater amount of nutrients out of the soil as well. So I've put this slide in when we're talking about the risk of compaction, risk of erosion. It is a large factor within agricultural land within the UK, but it is still a worry for everybody. So if you think about when you walk over your allotments or over the bare soil, you're pushing the air out of the soil, and particularly when the soil is waterlogged, squeezes the air out and makes it compacted. So you're pushing the soil particles closer together. And it's very easy to cause soil compaction very quickly and very difficult to alleviate it. So to try to get rid of this compaction, you've almost got to dig everything up. You've got to try to aerate the soil back again. Another problem is erosion. There's large areas at risk of erosion within the UK, and this is where and can happen in a number of different ways. So there's through wind, water are the main two factors within the UK. So we've got, when we have rain, instantly the second a raindrop hits the ground, you'll get a splash effect when the soil is bare. So for example, if you leave the soil bare over winter, when you're waiting for your to plant something in the springtime, actually putting in a cover crop, or it could act as a green manure, will prevent this erosion from occurring. So splash erosion, when it hits the soil surface. You can also get sheet erosion, so basically a whole area of the soil is washed off. Or rill and gully. This is usually on a sloping surface where the pathway of water droplets accumulate and they take the soil with them down the slope. And these can be very small gullies, very small rills, or they can become very large gullies as well. Wind erosion, not actually could be a problem in your area to a certain extent. So usually this is where you've got very light soil particles, usually sort of silt. The soil dries down, a lot of winds, and that will basically blow the soil off the surface. A big problem in the fens. And this does also relate to soil type. So understanding what type of soil you have will really help you understand how what are the main factors that could affect it. So for example, a heavy clay soil, more likely to suffer from waterlogging. This is because the soil particles are a platy structure, so they stick together, but it's also more likely to hold on to nutrients. A sandy soil, less of a risk of compaction, but also more of a risk of drought conditions, more of a risk of the nutrients getting washed out of the soil. Thinking about soil colour, really easy to look at and understand when you're in the allotments. There's a lot of different soil types in the UK. I think we've got about 600 different soil types. And actually getting an understanding of what they are does also relate to colour. So if it's a reddish soil, that's likely to have some kind of iron oxide component. If it's a very dark soil, that means you've got a lot of organic matter. That's really good. So the darker the soil, the blacker the soil, the more organic matter there is. If it's looking washed out or grey, that's likely because it is. So the soil will, so the nutrients will have got washed out and there'll have been a waterlogging occurring as well. And I really like this diagram here. So this illustrates the difference in organic matter between 3 different soils. And what you can see from the palest on the left to the darkest on the right, there's not a large percentage difference in organic matter, but it does have a large effect. So the one on the right with the 3% organic matter content, it's a lot darker. So firstly, that will mean that the soil will warm up quicker due to black being capturing the solar heat better. It will also, because of this organic matter, hold on to more water. Now, not in a waterlogging sense, but just be able to cope with more water. So organic matter, when water is added, it usually expands and holds onto the water. It makes that available to the plants in times of drought. And also it can, instead of being waterlogged, it's just part of the soil structure in comparison to the one on the left, which might end up being waterlogged. And actually does look a bit washed out. So what I'm assuming everyone's living in the UK at the moment, but you know, the UK, it quite often gets extreme weather events, and actually these have been, in my mind anyway, I don't know if it's just that I quite like watching the weather or whether it's because the acceleration of actual extreme weather events has happened. So we think about from 2012, we had, so in fact it's the 9-year anniversary of this event today actually. So in 2012 we had the wettest summer in 100 years, and in Aberystwyth, which is where I did where I moved job, it was a month after this event actually, they had about over a month's worth of rainfall in one day, all on Aberystwyth, at the same point as the high tide from the 2 rivers, which led to a massive flooding event. As I say, it was the wettest summer for 100 years. Also within agriculture, it ended up with a lot of compaction occurring because farmers needed to harvest their crops. So they drove onto the field with their combines when the soil wasn't able to cope with the field movements. But because of the farming year, you have to harvest your crops at that time. So it ended up being quite disastrous for soil. 2013 was the coldest spring for 50 years. 2013 and 14 was the wettest winter on record. And 2014, 2015 was the warmest year on record to date. Monthly extremes in 2016, 2017 again, warmest year on record. 2018, east from the east. 2019, we almost had the Whaley Bridge collapse and flooding. 2020, we had some very large storms, Kira and Dennis. And then COVID hit and people sort of didn't really think about the weather anymore. But even then, we're still, I mean, we've had, I think it's one of the sources today actually, that Europe has had one of the coldest springs for the last 10 years as well, this year. And May has been appalling. So as somebody who likes talking about the weather, you can see why it's really important to think about how resilient the soil is and how often we're getting these extreme rainfall events. Well, we've just had the hottest decade on record as well. So a number of different things have been happening across the last sort of 10 years, where each year there's been an extreme of one thing or another. So it has become more and more difficult to actually have profitable yields as a farmer, but also when you think about your allotment. My hydrangeas have got frost damage because I kept them in my house until after Easter. In fact, it was even after that. It was probably mid-April, and then we had some frost and all the flowers got frost damaged. So you need to think about what's happening and how you can grow your crops effectively, how you can grow in your allotments and your gardens, and what might affect it. That leads me perfectly onto soil health. So what is soil health? It's quite often referred to as the continued capacity of a soil to function. So in effect, that could be whatever the function is that you want. It could be if you're a farmer, to grow crops, if you're a gardener, to grow my hydrangeas and all the beautiful flowers that are out at the moment. But what I like to point out is that I'm talking about soil health. Now, soil quality, okay, that can be the chemistry, the physics, but soil health is effectively you're unconsciously acknowledging that you have to be alive to have health. You don't have a healthy table, for example. You have a good table. If you're having a healthy soil, that must mean it's alive with organisms living there that are actively helping plant growth. And it actually is, it's this combination of the physics, the chemistry and biology all together. So what makes me talk about soil biology? Soil is home to about 1/4 of all living species. So it's got a huge, huge biodiversity, and it's often been referred to as the poor man's tropical rainforest, because you've got more organisms living below ground in a rainforest in every soil than you have in a rainforest above ground. So really important when you're considering what's there beneath your feet. However, soil science, or at least before I started talking about it, was often taught emphasizing the physics, the chemistry, and not talking about the soil, the biology component. Mainly because biology only makes up about 5% of the soil, but it's still really, really important. So think about if you visualize an arable soil in a hectare, you have about 5 tons of soil fauna living below ground. So that's like 100 sheep. Or it's the equivalent of a cow of bacteria, or 5 sheep of protozoa, or 24 rabbits of mesofauna. Now, what are mesofauna? I'm sure you've all seen them, but so within the soil, you've got a large difference in size of the organisms living there. Small, medium, large. So you've got your small, your micro, your bacteria, your fungi, your mesofauna, springtails and mites, which I'll go on to in a second, and your macrofauna like your earthworms. Now, these mesofauna, the springtails, have got such amazing beauty and are really, really amazing creatures. And these are the ones driving decomposition and nutrient cycling in the soil. These ones are mites. These are, the one on the left is predatory, the one on the right is another decomposer. Then you've also got things like pseudoscorpions, which you might see in your compost pots, patches, boxes, I don't know, compost pots. And these ones are predatory as well. And these all together make up the soil food web, and they all eat each other and drive all of the interactions occurring. And finally, you've also got earthworms, which are hugely important and also make up one of the largest biomass components as well. So about 3 tons of earthworms per hectare. So greater weight of earthworms living below ground than livestock above ground. So equivalent of about, I think it's about 24 sheep of earthworms just below ground. And they can be responsible for 90% of water infiltration. And that was just in arable. So in a grassland system, you've got about 50 tons of soil fauna, or 2,000 sheep. Now, earthworms, these are often referred to as ecosystem engineers. They're the ones driving nutrient cycling. They're moving the soil around. And they're also quite a useful way of gauging if you've got a healthy soil or not, because these ones are, you know, the top of the food chain. If you've got a lot of earthworms, then the rest of the food web is probably in place. So we've got a number of different types. You've got ones that live on the topsoil that eat the recently fallen surface litter. You've got your horizontal burrowers, the endogeics, that eat soil basically, and they make it a better soil. And then you've got the large vertical burrowers that go up and down the soil profile and take plant material from the top, and they pull it down, and it decomposes within the soil, and then they consume it there. Now in the UK we've got about 30 species, and these are the ones that cross the channel before the channel, the water came across after the last glaciation event. And how they live, how long they live, and how many babies they have, all depends on which species. Now the small epigeics, they're very fast turnover of numbers. So about 3 months to a year, you get more species. The vertical burrows, the big anesic ones, they can live up to 10 years, but they don't reproduce very quickly. This is just a quick visual representation of it, which you can see there are 6 different species of earthworms in this little video here. And so the pale grey ones, those are the endogeics, the horizontal burrowers. That big black one in the middle, that's one of those vertical burrowers, but it's only a baby, it's not even a mature species. And then you've got a little black-headed worm in the center. That one is an epigeic, that's one of the surface dwellers, and that one is actually an adult as well. So you can see that there are very easy to see visual differences between the different earthworm species that you've probably not considered before. So just to conclude, because I'm probably already over time, just wanted to show you soil biodiversity, and it will vary depending on what crop, what food is available, and how you've established the crop. So digging a lot or ploughing disturbs that habitat, and also the climate will affect them as well. And the more stable the environment is, so the less digging, the less turning their house upside down, and the more food that's provided, the more amounts of organic amendments that are put in, the more likely you'll increase your soil biodiversity populations. And the healthier soil is, the more resilient it will be to these future weather extremes that we're getting.